Stellar storms beyond our sun. Evidence of extreme space, weather around distant stars, stellar storms beyond our sun. Evidence of extreme space, weather around distant stars. Astronomers have, for the first time, definitively observed a massive eruption of charged gas from a star beyond our sun, confirming that such violent space, weather events are not unique to our solar system. This discovery has significant implications for the search for habitable exoplanets, particularly those orbiting the most common type of star in the Milky Way, red dwarfs. The discovery, a coronal mass ejection, CME, confirmed the eruption originated from a red dwarf star, St. KM 11262, located approximately 130 light-years away. Scientists identified the event as a coronal mass ejection, CME, a burst of magnetized plasma similar to the solar storms that cause auroras on Earth. However, this CME was far more extreme than typical solar events. The key to identifying it wasn't visual observation, but the detection of a distinct 2-minute burst of radio waves escaping the star. This kind of radio signal just wouldn't exist unless material had completely left the star's bubble of powerful magnetism, explained Joe Collingham of the Netherlands Institute for Radio Astronomy. The findings, published in Nature, were made possible by data from the Low Frequency Array, a continent-wide radio telescope network, and the XMM Newton Space Observatory. Why this matters? Exoplanet habitability at risk. The discovery is critical because red dwarf stars are the most abundant stars in our galaxy, and they frequently host planets within their habitable zones. However, these habitable zones are much closer to the star than Earth's orbit, exposing any orbiting planets to intense radiation and frequent, powerful stellar storms. The ejected material from St. KM 11262 was moving at approximately 5.37 million mph, a velocity rarely seen in solar CMEs. Such force could easily strip away the atmospheres of nearby planets, leaving their surfaces barren and exposed to lethal radiation. This raises serious questions about the long-term habitability of planets around red dwarfs, despite their prevalence. Space weather and planetary atmospheres. The ability of planets orbiting red dwarfs to retain their atmospheres is a major unknown. While Earth's magnetic field and atmosphere shield us from the worst effects of solar storms, as seen in events like the 1989 Quebec power outage, planets around red dwarfs lack such protection. Researchers are actively studying this issue using advanced telescopes like NASA's James Webb Space Telescope. A high-priority observing program, led by Nestor Espinosa, aims to detect atmospheric carbon dioxide on rocky exoplanets using a technique called the secondary eclipse method. The Hubble Space Telescope is also studying the ultraviolet radiation output of these stars to assess their potential impact on planetary habitability. Implications for the search for life. If future observations confirm that rocky planets around red dwarfs cannot hold onto their atmospheres, it would significantly narrow the search for habitable worlds. However, even this negative result would be valuable, highlighting the unique conditions that allowed life to flourish on Earth. If you found out that none of them have atmospheres, that would be pretty sad, but also pretty interesting. It would mean that our planetary system is actually really, really special, Espinosa stated. Future observatories will continue to monitor stellar eruptions and map their influence on exoplanetary environments, providing a clearer picture of where the most promising candidates for life might reside. This discovery underscores the importance of understanding space, whether beyond our solar system, in the quest for habitable worlds.